All right, so this time we're going to look at graphs of other trig functions. We're going to look at secant, cosecant, tangent, and cotangent. And in order to look at those, we're going to refer back to the sine and cosine graphs, because every one of those four trig functions, secant, cosecant, tangent, and cotangent, can be written in the form of sine or cosine. So let's start off with secant and cosecant. So let's remind ourselves about how they're related to sine and cosine. So remember that secant and cosine are reciprocal functions. And then likewise, the same thing's going to happen with cosine and sine and cosecant. So if secant and cosine are reciprocals, then we can rewrite y equals secant x as y equals 1 over cosine. And we're going to look at this ratio right here to help us with a graph of secant. Now, because there are going to be values of x that make the denominator equal 0, we're going to have some vertical asymptotes. So let's look at these two graphs together. So I kind of have them both set up right here. I don't have the graph of secant finished, but last class we did look at the graph of cosine. So remember, at these x values, cosine x will have these y values. And then I've plotted the graph right here. And so like I said, we saw this last class. Now remember, secant is the reciprocal of cosine. So I'm taking the same table over here, except I'm taking the reciprocal of all of these y values. So at x equals negative 2 pi, y will be 1 over 1, which is still equal to 1. But at negative 3 pi over 2, if cosine is 0, secant will be 1 over 0. And we know whenever you have 0 in the denominator, it's undefined. At x equals negative pi, cosine is negative 1. So at x equals negative pi, secant is 1 over negative 1, which is negative 1. And then so on and so on. That's how I did the rest of this table. So I just took the reciprocal of all of these values. And everywhere that cosine was 0, secant's going to be 1 over 0, which makes it undefined. Okay, so now how does that translate to a graph? So over here on the left, I have the graph of y equals cosine x. Over here on the right, I have the setup for the graph of secant x, but I don't actually have it yet. What I do have, though, is a little outline of the cosine graph. And oftentimes you're going to see when people are graphing secant or cosecant, they'll graph the corresponding sine or cosine graph. So here's what we do. Now notice when I graphed it cosine, I didn't actually graph it with a solid line. It's dotted because this is not the actual graph. This is just going to help us. Kind of like asymptotes aren't part of the actual graph. They're just lines to help us. So what I'm going to have is everywhere that cosine was 0, secant is going to be undefined. I'm going to have vertical asymptotes. So I have vertical asymptotes right here, 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 and here. And then everywhere that cosine was 1, secant will also be 1. Everywhere cosine was negative 1, secant will also be negative 1. So when the cosine was 1, so will secant. When cosine was negative 1, secant will be negative 1. When cosine is 1, and then so on. Now what's going to happen is the reciprocals, instead of making this one nice continuous curve, we're going to have these U-shaped graphs in there. They're not parabolas, because parabolas have a very distinctive U shape to them. They're just other U's. And that ends up being what our secant graph looks like. And I mean, if we think about it, it kind of makes sense. So first of all, in this interval, cosine's positive, and 1 over a positive number will still be positive. So it makes sense for secant to also be positive. Another thing to keep in mind is that, like, let's say at this value, y is 1/2. Well, the reciprocal of 1/2 is 2. So the y value is 2. It's much greater. And that's what's happening is these values that were less than 1, when we take the reciprocal of them, they become greater than 1. And that's what's making the graph go up like this. And then likewise here, all of these values are negative. So it makes sense that the reciprocal of negative values would still be negative. But these values are between 0 and -1. So when you take the reciprocal of them, they're going to be less than -1. And that's what makes these U-shapes. And so that's what we do. When we graph a secant graph, we'll graph the corresponding cosine graph to help us figure out where the asymptotes are going to go. And then that tells us also where the U-shapes are going to go. So let's see what sine or cosecant would look like. And you'll see it looks very similar. Here's kind of both of them put together. So here's the graph that we, actually right here, this is the, no, we just did secant. Here's the graph for secant that we just did. And then cosecant, we do exactly the same way. Since cosecant is the reciprocal of sine, you can see I've got the outline of the sine graph here. And then everywhere that sine was 0, we have a vertical asymptote. And everywhere that sine was 1, cosecant is also 1. And so we have these U-shapes that touch at the maximum and minimum values. And there you go, there's your graphs. Now, if we talk about periods, in order to complete one cycle, it's still going to be 2 pi. So if I start at 0 and go to 2 pi, you can see that that completes one cycle of the graph. So the period for cosine was 2 pi. The period for its reciprocal is still going to be 2 pi. But we don't really talk about an amplitude. Only sine and cosine graphs get an amplitude. It doesn't make much sense to talk about how high or low a graph goes. So we don't have an amplitude for the secant or cosecant graphs. And then as far as the vertical asymptotes, you'll see it described like this. So let's look at what this means. If we take the first positive value where vertical asymptote is, that's pi over 2, and that's usually what we do. We take the first positive value, pi over 2, and then if you look, they're all evenly spaced, and they're all pi units apart. So this plus pi n, if n is an integer, that just means a multiple of pi, sorry. So we're going to start at pi over 2 and add or subtract, because integers can be negative, any multiple of pi, and that will tell us where the other vertical asymptotes go. And then cosecant's very similar. Still the period is 2 pi, because the period of sine was 2 pi. The period of its reciprocal is still 2 pi. We still don't have an amplitude. And then as far as the asymptotes here, the first asymptote actually happens when x is 0, so we'll pick that one. But they're still pi units apart, so plus pi n. You'll see it written as 0 plus pi n, or often just pi n. We don't need the 0. And so there you go. There's your secant and cosecant graphs. Okay, so now let's take a look at tangent and cotangent graphs. So we're going to look at them kind of the same way. We're going to look at them by referring back to sine and cosine. So remember, tangent can be written as sine over cosine, and cotangent can be written as cosine over sine. So we can get some information here. First of all, vertical asymptotes. Tangent will have vertical asymptotes anywhere where the denominator is 0. So anywhere where cosine is 0. Tangent has vertical asymptotes. Cotangent will have vertical asymptotes anywhere that sine, the denominator here, is 0. So cotangent has vertical asymptotes when sine is 0. Also, if sine and cosine happen to have the same value, then we know that tangent will be 1. So tangent and cotangent both will have a value of 1 when sine and cosine are equal. And we know that tangent and cotangent will have a value of -1 if sine is the opposite of cosine. And so then here I just kind of looked at where does sine equal cosine and where does sine equal negative cosine. And if you refer back to what we did last semester, we know that sine and cosine will be equal when x is pi over 4, or 45 degrees, and 5 pi over 4. And then they'll be opposite at 3 pi over 4 and 7 pi over 4. So let's put all this information together to help us graph these. So that's what I'm doing here now. Remember that tangent is sine over cosine. So at x equals 0, sine is 0, but cosine is 1. So 0 over 1 is 0. At pi over 4, sine is root 2 over 2, and cosine is also root 2 over 2. They're equal, which we actually just stated over here. And so when you have the same thing on the top and the bottom, the fraction equals 1. At pi over 2, sine over cosine is going to be 1 over 0. We have a 0 in the bottom, it's undefined. And so that's what I've done here, is I've filled out the rest of these values. Notice I'm counting by pi over 4 on the x values here. So that's what I've got. So let's see what this looks like as a graph. So I have an asymptote at pi over 2, and there's pi over 2 right there. So let's go ahead and draw a vertical asymptote in there. I should also have a vertical asymptote at 3 pi over 2. So 3 pi over 2 will be here. And then we know with the regularity of trig functions, once I've got these, it's going to repeat over and over again. So I'm going to have another vertical asymptote here, all evenly spaced apart, because it's just a repeating function. It's a periodic function. And then same thing here. So I have all these vertical asymptotes. All right, so let's take a look then at these other values at 0, 1, -1, and so on. So at x equals 0, it equals 0. That's this point right here. At pi over 4, y equals 1. Pi over 4 is going to be halfway in between 0 and pi over 2. So that's going to put this point right here. Then I have my asymptote. Then at 3 pi over 4, it's -1. Then we're at 0, and then we're at 1. But then I got my asymptote. Then we're at -1, then we're at 0. And at that point, I'm off of my table, but you can see now the pattern that's going to happen. I'm going to have these 3 dots going up in between each set of asymptotes. So in between each set of asymptotes, it equals 0. And then we're at -1 and +1. So 0, but then you got -1 and +1. And so then if you think back to what we did with rational functions and what the graph is going to look like, you're going to have these nice little tangent graphs here. Actually, this is all the tangent graphs. These are just separate branches of the tangent graph. And there we go. So there's your tangent graph right there. Now, if you take a look, one period, this is one period right there. And the distance that it takes to repeat between pi over 2 and -pi over 2, that's actually a distance of pi units. This actually is the first time we're seeing a different period. The period of this graph is pi, not 2 pi. And again, we don't have an amplitude. So there's your tangent graph. Now we're going to do something very similar for the cotangent graph. So this one I'll go through a little faster. I've set it up again. Again, since cotangent is cosine over sine, I did cosine over sine for each one of these values and got these. You can see the same kind of thing. We got 1, 0, -1. We have the same kind of thing happening here, -1, 0, 1. We also have some places where it's undefined because that's where sine is 0. So I'm going to go ahead and just plot all this stuff. So starting at x equals 0, we actually have our first asymptote. So the y-axis is an asymptote. And then we have one at pi, and then we have one at 2 pi. So we have one at pi, we have one at 2 pi, and then we can see how they're being evenly spaced apart here. And then if I plot these points, pi over 4 is 1, so that's up here. At pi over 2, it's 0. And at 3 pi over 4, it's -1. So this time the dots go down, but it's very similar to the tangent graph. So I'm going to plot these points here, and then we'll put our curve. So this time it's the same kind of shape as tangent, but tangent was increasing. All of these branches are decreasing. Once I'm finished drawing them, I'll pull down the screen here, and you can see tangent, these are increasing, cotangent, these are decreasing, and then where the asymptotes are different. Here the asymptotes are symmetrical. Well, actually I'll say it like this. The y-axis is not an asymptote, but with cotangent the y-axis is an asymptote. But they are spaced pi units apart still. So we still have a period of pi for cotangent as well. Here is one period in between pi and 0. That distance is pi. So there's our cotangent graph. So I have a summary of it here, but actually even better, let's remind ourselves of all of the 6 trig functions. So we can see sine and cosine. Let's look at those first. So these two have similar shapes. They're really just, transformations of each other. But the sine, if you were to highlight one period of the sine graph, starting at 0, remember sine makes that S. For cosine starting at 0, cosine makes the cup. And they both have the same period. They both have an amplitude of 1. The domain, we haven't talked about the domain or range of these, but the domain on both of these is all real numbers. And the range, they go from -1 to 1. They just hop back and forth between -1 and 1. And sine is symmetrical about the origin, but cosine is symmetrical about the y-axis. Now then we can't speak. Then we looked at the cosecant and secant graphs. Again, if I highlight one period for cosecant, we can see that the period is still 2 pi. If I highlight one period starting at 0 for the secant graph, you can see that its period is still 2 pi. And remember, these, we don't talk about an amplitude. And then the domain is going to be the values of x where it's undefined, and it is undefined at the asymptotes. So for cosecant, all the vertical asymptotes happen at multiples of pi, which we say x equals pi n. So the domain is x can't equal pi n. And then the range, the y values can go from -infinity to -1, and then from +1 to infinity. And we want to include the 1 and the -1. This one has symmetry about the origin. This one has symmetry about the y-axis. But again, you can see that relationship between the domain and the vertical asymptotes. The vertical asymptotes for this happen at x equals pi over 2 plus pi n plus a multiple of pi. And the domain is x can't equal those values. So that was cosecant and secant. And then tangent and cotangent. if we look at those, again, the thing to keep in mind, one period, first of all, for both of these is only pi. So the period for the other ones are 2 pi, but only tangent and cotangent have a period of pi. Again, we don't talk about an amplitude. The domains are the values of x that are the asymptotes, because those are the only values of x for the function's undefined. The range is all real numbers, because these graphs go up and down forever. Tangent is symmetrical about the origin, and cotangent is also symmetrical about the origin. And then the vertical asymptotes. And then the thing to remember with the difference between tangent and cotangent is where the asymptotes are. So tangent is pi over 2, and then you go every pi units, and it's an increasing graph. Cotangent, the first asymptote's at x equals 0, and then you go every pi units, and it's a decreasing graph. So this is in the notes, but if you want to pause the video and write this down, and then if you want to pause the video to write the tangent, cotangent graphs. But now we'll look at graphing. So we're going to have 4 examples of graphing. Let's take a look at the first example. All right, so this is almost a regular tangent graph. The only thing is we have this 1/4 right there. So what does that 1/4 do? Well, if we think back to our transformations, we don't have like an amplitude or anything that we can talk about with, like we did with sine and cosine, but we do know that this is a vertical stretch, or a vertical dilation, I should say. Vertical dilation by a factor of 1/4. So what does that mean? Vertical means we're going to affect the y values, not the x values. So actually, if I go back here real quick, these x values, where my asymptotes are going to be, they're still there. It's going to affect the y values. So it's actually going to change where these points are. Instead of these points being at 1 and -1, these points are going to be at -1 times 1/4, or -1/4, and then +1 times 1/4. Remember, factor means multiply. So take your y values and multiply by 1/4. If my y value is a -1, then I multiply it by 1/4, and I get -1/4. If my y value is a +1, I multiply it by 1/4, and I get a +1/4. And that's the only thing this is going to do. So the asymptotes stay in the same place. It's just changing where these values are. So let's see. Now you can do this in a couple of ways. You could change your scale on your y-axis and put a 1/4 instead of 1. I'll show you what I mean. So I could label this with a 1/4 instead of a 1 if I wanted to. Just to get an idea of what it actually does to the graph, I'm going to leave this as a 1. It won't be that hard to graph. And I'm not compressing at all. I'm still going to just do pi over 2. I'm not compressing vertically. My period is still pi, is my point. Period. By the way, the period for tangent and cotangent would be pi over b. Not 2 pi over b, but pi over b. But in this case, it's pi over 1, so it's just pi. All right, so my asymptotes don't change places, so they're still in these same locations. And now when I put my points in between, here's how I like to do it. Halfway in between the asymptotes, I'm going to be 0. And then normally I'd be at -1 and 1. But remember, I have a vertical dilation by a factor of 1/4. So instead of being at -1 and +1, I'm going to be at -1/4 and +1/4. So I'm going to be here and here. negative 1/4, 0, positive 1/4, negative 1/4, 0, positive 1/4. And so now, when I go to draw my tangent graph, I have a much more pronounced curve to the graph. It's flattening it out even more because it's smushing it. And there's my graph. And again, pay attention to the directions. If the directions say draw exactly 2 periods, then only draw 2 periods. The directions will tell you something about how much to graph. It'll say either like include 2 periods, which means at least 2 periods, include 3 periods, at least 3 periods. Maybe it'll say exactly 1 period. That means it's also testing, do you know what a period is? If it said 1 period only, you'd only want to draw one of these branches, and that's it. Don't draw anything else. You can pick which branch you want to draw, but 1 period is 1 branch on the tangent graph. There you go. There's a tangent graph. If you compare this to up here, you can see, whoops, you can see how this is a much more stretched out graph vertically. Here now the curve is much more pronounced, and it's because of that dilation there. All right, so there's that guy. Let's look at graphing this. And by the way, on any of these, if you want to pause the video and try graphing it yourself first, definitely encouraged to do that. But let's try graphing this one. Okay, so it's still a tangent or cotangent graph. We have a couple of things going on here. In fact, if you think about it, we actually have 3 different transformations. That negative 3, first of all, we have a reflection in the x-axis. We have a vertical stretch by a factor of 3. And then the period is always pi over b, which in this case is pi over pi, or 1. So let's see how this is going to graph. There's no shifts, though. So, oh my goodness, that's a horrible. Now remember, with cotangent and tangent graphs, because 1 period happens right in between the asymptotes, the period actually tells us how far apart the asymptotes are spaced, which is kind of nice. So that means since our period is 1, we're going to space the asymptotes 1 unit apart. The other thing to keep in mind is for cotangent graphs, if there's no horizontal shifts, one asymptote will always be at x equals 0. And then you space them apart by whatever the period is. So let's do that. We're going to start with one asymptote at x equals 0. We want the next asymptote to be 1 unit apart. Remember, we have to graph stuff in between. So I'm going to make 2 squares be equal to 1 period on the x-axis. So that means my asymptotes are going to go here, here, and so on. I should actually put some more tick marks here on the x-axis. Okay, so we have that. And then, normally, cotangent is a decreasing graph, but we do have a reflection in the x-axis, so it's going to make it an increasing graph. To visualize it, imagine taking this graph and flipping it in the x-axis. So you can see this decreasing part, when you flip it, is going to become an increasing part. So we're actually going to make increasing branches here, vertical stretch of 3. So if I start in the middle at 0, on either side, I'm going to go up and down 3 units, but make sure your points are increasing. So this is going to be a very stretched out, elongated graph. It's going to be very hard to see any kind of twist or curve here. But this is it. Not a very pretty one. And there's your cotangent graph. Yay! Okay, let's take a look at another one. Okay, so this one's going to be a little weird because we have a vertical shift in there, and you'll see what happens with that. But let's look at like we did before, in order to graph secant and cosecant, we're going to look at the corresponding sine or cosine graphs. In this case, because secant's the reciprocal of cosine, we're going to look at y equals cosine pi x minus 1. So let's look at this guy. We know the period is 2 pi over pi, so it's 2. We know the amplitude is 1. Remember, when I say amplitude here, I'm talking amplitude of cosine, not secant. And we have a vertical shift down 1 unit. So let's see what this looks like. Let's set up my axes here. And because my period is 2, 1, 2, 3, 4, I'm going to make 4 squares equal 2. That means 1 square is equal to 1/2. I don't have any kind of reflection or anything. So normally, I'm going to just draw a little quick sketch here, but normally before any shifts, our graph would be here. Oh, that's really bad. But I'm going to just shift everything down 1 unit. So I'm going to start here. Instead of starting up at 1, I'm going to start here. And then that would be my cosine graph. Oop. I did that wrong. I did that wrong over on the right-hand side there. That point shouldn't be there. It should be here. That looks better. So there's my cosine graph. Now this is where it's weird, because remember we looked at everywhere the cosine was 0, that's where your asymptote is. Remember, I've got a shift. So we're not going to look at where the shifted graph equaled 0. We still want to look at where the graph before the shift would have been 0. And we can kind of see that at these middle points. That's where the graph would have hit the x-axis. That's where your asymptotes are going to be. Remember, vertical shifts don't move vertical asymptotes. So that's the weird part that you have to think about with the with the secant and the cosecant graphs. Don't look at where the shifted graph equals 0 of cosine or sine. Look at where the unshifted graph would have been 0. So basically, once you do your little sketch of the corresponding cosine or sine graph, take those middle points. That's going to tell you where your vertical asymptotes should be. But once we have those, where there was a relative max for the cosine graph, it's a relative min for the secant graph, and then vice versa. We still have those same U-shapes. So there is our secant graph. Once you get the sine or cosine graph drawn, the secant or cosecant graph, super easy. So let's look at one more. We'll look at a cosecant graph. Again, I would encourage you, pause the video and try this on your own if you haven't done that yet. Okay, so let's take a look at what we got here. Again, we're going to look at the corresponding, in this case, reciprocal of cosecant is sine. So we're going to look at y equals -2 sine 4x plus 2. So we have quite a bit going on here. The negative means we have a reflection in the x-axis. Amplitude is 2, period is 2 pi over 4, or pi over 2. And phase shift is 0. That plus 2 is a vertical shift, up 2 units. Okay, so let's draw our graph here. Once you've done last night's homework and gotten the hang of drawing sine and cosine graphs, it becomes a little easier to do the shifts also. So again, since my period is pi over 2, I'm going to make every 4 tick marks be pi over 2. That means 1 is pi over 8. So I have a scale there that's going to help me draw my graph. And I'll count by ones here. All right. So it's a sine graph. Now, a sine graph would normally make an S shape like this. However, we have a reflection, so it's going to be like that. I'm going to start at 0, go down, back to 0, up, back to 0. I'm going to go ahead and take into account my shift. So normally I would start at the origin and then go up and down. But because I'm shifting up 2 units, I'm going to start up here and then go up and down. But actually, I should say go down and up because I've got that reflection. So I'm going to start up here. Now remember, my amplitude is 2. So I'm going to start up here and go down 2, back to the middle, up 2, back to the middle. Down 2, back to the middle, up 2. And I'll do the same thing backwards. Up 2, back to the middle, down 2, back to the middle, up 2, back to the middle. And that's where my sine graph would go. Now, it's not really my graph. So I'm just going to put a dotted line here. Now again, I had a vertical shift, so I have to be careful where I put my vertical asymptotes. My vertical asymptotes are not going to be where this graph hits 0. It's going to be where the unshifted sine graph would have been 0. So it's at those middle points. This point, this point, this point. These x values are going to be where I've got my vertical asymptote. But once I have those, I can draw my U shape. Just make sure I come up and just give that sine graph a little smooch, a little kiss on the cheek, and then run away. Give it a little kiss, run away. And there we go. Oh, this is a messy graph. Sorry about that. So there you go. There's your graphing of your other trig functions. So, yeah, have fun with the homework, and I'll see you in class. Bye.